Over 4 billion years ago. A Big Bang. Form. The Earth. About 4.57 billion years ago, the Sun created disk-like dust and gas clouds called the solar nebula. These dust and gas clouds form planets in the solar system, and the Earth is one of them. The process of forming the Earth was completed within 10 million to 20 million years. Initially in the molten form, the Earth's outer layer cools to a solid while water begins to accumulate in the atmosphere. Emissions and volcanic activities create the early elements of the atmosphere. Condensation is enhanced by ice, and liquid water is provided by meteors and larger asteroids, comets, and objects farther than Neptune create oceans. Earth is the third planet from the Sun with the largest size of other rocky planets in the same solar system when compared to its radius, mass, and material density. At the same time, it is the only astronomical object currently known to have life. The Earth has a satellite called the Moon. The Moon revolves around the Earth and revolves around the Sun. In addition to the Earth itself orbits its axis to create the phenomenon of day and night. The Earth's surface is divided into tectonic plates, which move slowly over the Earth's surface over millions of years. About 71% of the Earth's surface is covered by saltwater oceans, the rest are continents and islands. And water is also the most important factor for the formation and maintenance of life to this day. The Earth has the greatest density, the greatest surface gravity, the strongest magnetic field, the fastest rotation speed. And at the same time it is also the only rocky planet on which the tectonic plates are still active. The shape of the Earth very close to the sphere is that the sphere is compressed along the direction from the pole to the equator's bulge. This bulge is a result of the rotation itself and makes the diameter of the diameter at the equator 43 kilometers longer than the diameter from pole to pole. The largest deviation from the Earth's surface is Mount Everest, 8,848 meters above sea level, and the Mariana Trench, 10,911 meters below sea level. Due to the swell in the equator, the furthest center of the Earth is the Chimborazo Peak of 6,268 meters in Ecuador. The Earth has a solid silicate crust on the outside. The mantle is very viscous, the outer core is liquid and less viscous than the mantle, and the inner core is solid. The structure of the Earth can be determined in two ways, including chemical or mechanical properties such as rheology. Mechanically, it is divided into 5 main layers including lithosphere, soft book, middle coating, outer core, and inner core. Chemically, it is divided into a shell, an upper mantle, a lower mantle, the outer core, and the inner core. Earth core, also known as Earth's human. According to the physical characteristics based on the characteristics of waves transmitted, people divide the core into 2 layers with different wave response characteristics. The outer layer or outer core is said to be in liquid form, while the inner layer or inner core is said to be the solid with the highest density of the Earth's layers. Based on the theory of mass separation, it is thought that the core region is composed of iron, 88.8%, with small amounts of nickel, 5.8%, sulfur, 4.5%, and other elements are less than 1%. Earth's mantle or mantle is chemically divided into layers. The coating is the highest viscosity layer below the shell and above the outer core. The Earth's mantle is a 2,900 kilometers thick rock crust that accounts for nearly 70% of the Earth's volume. It is mostly solid and located on an iron-rich core of the Earth, accounting for nearly 30% of the Earth's volume. Past melting and volcanic periods at the shallower points of the mantle have created a very thin crust containing crystallized molten products near the surface on which all forms of life take place. The gases released during the melting process of the Earth's coating have a great influence on the composition and popularity of gases in the Earth's atmosphere. Earth's crust is the outermost layer of the Earth, in solid form. The rock constituents of the Earth's crust are almost all oxides. Components such as chlorine, sulfur, and fluorine are the only important exceptions to this ingredient, and their total mass in any conventional stone is less than 1%. F.W. Clark calculated that nearly 47% of the Earth's crust is oxygen. The crust is divided into two types according to the extent of distribution, and its physical and chemical characteristics are continental and oceanic crust. The ocean crust is 5 kilometers to 10 kilometers thick, and is composed mainly of basalt, diabase, and gabbro. The continental crust is 30 to 50 kilometers thick and is composed of rocks that are lighter than oceanic crust like granite. The Earth's mechanically hard outer layer, the lithosphere, breaks into pieces called tectonic plates. These arrays move relative to each other in one of three types of array boundaries, converging when two arrays collide, splits as the two plates push each other apart, transforming as the plates slide along the fractures. As the tectonic plates move, the ocean floor is subducted at the edge of the continent or at the converging boundary. Meanwhile, the eruption of magma at diverging boundaries creates ridges in the ocean. The combination of these processes pushes the ocean crust back into the mantle. Because of this recycling process, most of the ocean floor is not more than 100 million years old. The oldest oceanic crust is in the western Pacific Ocean and is approximately 200 million years old. Besides, the oldest continental crust is about 4,030 million years old. Other continental plates include the Indian Plate, the Arabian Plate, the Caribbean Plate, the Nazca Plate on the west coast of South America, and the Scotia Plate in the southern Atlantic. The Australian Plate actually merged with the Indian Plate between 50 and 55 million years ago to form the Indo-Australian Plate. The fastest moving plates are the ocean plates, with the Cocos moving at a rate of 75 mm per year and the Pacific Plate moving at 52 to 69 mm per year. At the other extreme, the slowest moving plate is the Eurasian Plate, which moves at a normal rate of 21 mm a year. The topography of the Earth varies from region to region. Water covers about 70.8% of the Earth's surface, with most of the continental shelf below sea level. The rugged undersea surface consists of a system of mountain ranges between the oceans spanning the globe, such as underground volcanoes, ocean trenches, canyons, oceans, and plain bottom. The remaining 29.2% is not covered by water, including mountains, deserts, plateaus, plains, and other terrains. Earth's atmosphere is the outermost layer of the Earth, composed of soil and affected by soil formation processes. It exists with the lithosphere, atmosphere, hydrosphere, and biosphere. Hydrosphere. The abundance of water on the surface of the Earth is a unique feature that distinguishes the green planet from other planets in the solar system. Earth's hydrosphere mainly consists of oceans, but theoretically it includes all water on the surface of the land, including the inland sea, lakes, rivers, and groundwater at depths up to 2,000 meters. The deepest area on the seafloor is the Challenger Deep of the Mariana Trench in the Pacific Ocean with a depth of 10,911.4 meters. The average depth of the oceans is 3,800 meters, which is more than 4 times the average height of the continents. About 97.5% of water contains salt, the remaining 2.5% is fresh water, and most of fresh water, about 68.7%, is in the form of ice. About 3.5% of the total mass of the oceans is salt, and much of it is ejected from volcanic activity or separated from cold magma rocks. The oceans are filled with water-soluble gases, essential for the survival of marine life. The atmosphere is a layer of gas that can layer is called the troposphere, where the sun will heat it and the surface of the earth will expand the air. This low-density gas layer flies upwards, replaced by a cooler, denser gas layer. Above the troposphere, the atmosphere is divided into stratosphere, middle stratosphere, and thermal layer. Each floor has a different rate of temperature decrease. Above these levels, there is a thin outer layer that enters the magnetosphere. This is where the Earth's magnetic field interacts with the solar wind. A part of the atmosphere that is important for life is the ozone layer, a part of the stratosphere that blocks ultraviolet rays. The Kármán Road is located at an altitude of 100 kilometers above the surface of the Earth, which is the boundary between atmosphere and space. The magnetic field appears due to the magnetic properties of the constituent matter of the Earth. The Earth's magnetic field exists from within the Earth to the vast space surrounding the Earth. The cause of the magnetic field can be explained by geodynamo theory. The Earth's magnetic field is considered to be a magnetic dipole, with one pole near the geographic North Pole and the other pole near the geographic South Pole. An imaginary ascending line connecting the poles forms an angle of about 11.3 degrees from the Earth's axis of rotation.